Rajshahi, Higher Maths, 2017, question 4c. If the three medians AE, BF and CD of triangle ABC meet at O, prove that AB squared plus BC squared plus CA squared equals 3 into AO squared plus BO squared plus CO squared. Well, to solve this, we need to draw a diagram. In the diagram, draw a perpendicular from C to AB. In triangle AGC, AC squared is equal to AG squared plus CG squared. But if we look, we can see AG is equal to AF minus FG. Now substituting that in, we get AC squared equals AF minus FG all squared plus CG squared. Now if we expand the brackets, we get AC squared equals AF squared plus FG squared minus twice AF FG plus CG squared. Now if we look in triangle BGC, BC squared equals GB squared plus CG squared. That's Pythagoras' theorem. But GB equals BF plus FG. We can substitute that in to get BC squared equals BF plus FG all squared plus CG squared. If we expand the bracket, we get BC squared equals BF squared plus FG squared plus twice the product, 2BF times FG plus CG squared. But we know BF is equal to AF, so that equation can be written as BC squared equals AF squared plus FG squared plus 2AF FG plus CG squared. Now if we add on the equation 1, we get AC squared plus BC squared equals 2AF squared plus 2FG squared. Now the next terms cancel out, you've got a plus amount and a minus amount, and so you're left with at the end plus 2CG squared. Now if we look in triangle CFG, again using Pythagoras' theorem, FG squared plus CG squared equals CF squared. And we can substitute that in 3. The 2FG squared plus 2CG squared becomes 2CF squared. So we have AC squared plus BC squared equals 2AF squared plus 2FC squared. That is actually Apollonius' theorem. And we can do exactly the same again to get BA squared plus CA squared equals 2BD squared plus 2AD squared. We can do it a third time using the third median, CB squared plus AB squared equals 2CE squared plus 2BE squared. If we look at the last 3 lines, add them together and double them, we'll get 4 into AB squared plus BC squared plus CA squared equals 4 into AF squared plus BD squared plus CE squared plus 4 into CF squared plus AD squared plus BE squared. But because F is the midpoint of AB, we have 2AF is equal to AB. So if we square both sides, we get 4AF squared equals AB squared. Similarly, we can get 4BD squared equals BC squared, and 4CE squared equals AC squared. So if we add them together, we get 4AF squared plus 4BD squared plus 4CE squared equals AB squared plus BC squared plus CA squared. But we've already had 4AF squared plus 4BD squared plus 4CE squared above, so we can substitute that for AB squared plus BC squared plus CA squared. Now if we look at the result we've got the bracket AB squared plus BC squared plus CA squared on both sides. On the left hand side it's 4 times, and on the right hand side it's once. So if we subtract it from both sides, we'll end up with 3 into AB squared plus BC squared plus CA squared equals 4 into CF squared plus AD squared plus BE squared. But we know the medians intersect each other 2/3 of the way down the line. So AO is 2/3 of AD. So that means 3AO is equal to 2AD. And if we square that, we get 9AO squared equals 4AD squared. And we can similarly get 9BO squared equals 4BE squared, and 9CO squared is equal to 4CF squared. So 9 into CO squared plus AO squared plus BO squared is equal to 4 into CF squared plus AD squared plus BE squared. Now we can substitute the 4CF squared plus AD squared plus BE squared for 9 into CO squared plus AO squared plus BO squared. Now if we divide both sides of that equation by 3, we get AB squared plus BC squared plus CA squared equals 3 into AO squared plus BO squared plus CO squared, which was what we were required to prove.